And welcome back. Yes, this rather lonely looking ESP32 sitting on my desk here. Yeah, what's that all about? Well, we're all talking about web servers today and how we can get connectivity to that device on my workbench using either the Arduino IDE 2.0, the new one, or Visual Studio Code running PlatformIO. And I'll show you both ways of doing it, and it will make your sketches so much better when you can control your device from, say, your phone or any other browser. Let's have a look. I want to give a big shout out to PCBWay, PCB prototype the easy way. Now, we're all well aware of the $5 for 10 pieces PCB, but I've got some real practical examples that I've ordered recently. Let's have a look at those. So here we have a very small double-sided panelized board that enables me to create a tiny little display unit. Look at that, how cool is that? And at the other end, look at this pond controller. Mains voltage, absolutely wonderful. That looks pretty cool too, doesn't it? And that's been running for some time now. Yeah, PCBWay has excellence in their PCB department, but that's not all they do. Look at this. Just look at their products and capabilities. Apart from printed circuit boards of all types, they do PCB assembly, double-sided, through-hole, surface mount, you name it, which means you can design a prototype for yourself or your company and have it assembled by PCBWay for the cost of the shipping. And if you want some 3D printing done, these are the people to do it for you as well. PCBWay. Why don't you try them out now? Yes, now if you can imagine an ESP32 or any other web-enabled microcontroller, but I'm focusing specifically on the ESP32. It will work with the ESP8266 as well, but I haven't done it here. You want to be able to control something that's running on that device, yeah? Like I've shown you in the last few videos where I've got my pond controller over there on the wall doing stuff to the pond. I've got my smart heater controller on the wall down here controlling the heating and the fan and taking sensor readings from the attic and all that. But I want to be able to see what's going on and potentially direct it to make it do something else. Yeah. So I've had so many comments and queries saying, how do I do this? And I'm using a different Wi-Fi library and it's not working with the OTA, and oh dear. So I thought, right, let's start from basics. I'm going to show you the framework that I use with the 3 libraries that I use that are absolutely guaranteed to work, and the order in which you put them, and how we can generate a very simple web page that you can fire up using any browser of your choice, whether it's on your phone or on your desktop or on a tablet sitting in the lounge. As long as you can connect into your Wi-Fi using both that device there on the workbench and your device, phone, tablet, whatever, PC, Mac, then you'll have access to that device. You can either have a quick check to see what's going on, as I do most days actually, to see what the temperature's like in here. And you can then say, I want you to do something now because I've pressed a button, just like you would on any other web page. You know, Amazon, you say, buy now, don't you? Well, on my smart heater controller, I can say, turn the heating on. And I'm in the kitchen or wherever it is inside the house, and suddenly the heating turns on here. My fan turns on, and by the time I get in here, it's lovely and warm. But we're just going to do a very simple web page just to get the basics done. Now, prerequisites. What do you need? Well, obviously you need something like that device I'm showing you there that will connect to your Wi-Fi. Any ESP32 development module will do. Doesn't have to be any particular brand. I always use the ESP32 dev module framework anyway in my work, so it's not specific, and that works absolutely fine. And what else do you need? Well, ideally a knowledge or at least an appreciation of HTML, because that's what web pages are written in. Yeah, now HTML, if you've never done it before, initially looks a bit gobbledygook, but the example I'm going to show you lays it out nice and neatly, and it's short. I'm going like that because I think that's how much room it takes up on the screen. And it's pretty obvious what it does. But of course, if you want to continue that and expand upon it, you will have to go away and learn a little bit of HTML. Not a huge amount by any means. Now there's other things you can throw into the mix if you really want to. If you know CSS, that's cascading style sheets, that's great because you can make your web page look nice and pretty. If you know JavaScript, that's great because you can make it do things as well. Okay, enough waffling. Let's have a look at the end result really of what we're trying to do here, just to prove that it works. When we've built our code on that device and we've uploaded it to that device, and more importantly, that device then has run the code to connect to our Wi-Fi, I want to be able to go to my phone or whatever it is and go, connect, show me something, which is normally called the landing page. When you go into a device, a home page, yeah, it's the landing page. It's where people come in and they land on your website. Well, that's exactly what we're going to do here. And it looks a bit like this. Whoa, get the sunglasses out. That's a bit bright, isn't it? But it proves, and I'll show you in the code how we can change this. It proves that we've done something to that ESP32 to enable it to generate this sort of stuff. Yeah. Now this is the landing page, as I say. If you look at the browser's address at the top of that web page up here where it says 192.168 blah blah blah, I'll talk about that, but that's the local address inside your Wi-Fi network. There's another particular page though we want to show, which is very, very useful because it means once you've uploaded this code, you can then upload all future code over the air. You do not have to connect a USB cable to that device anymore in order to upload the code. It just does it over the air like magic and then reboots itself and it goes, oh, I'm running new code now. I'll show you how that works as well. But let's have a look at the next page I want you to look at, and this wasn't written by me. Right, now this is called ElegantOTA, over the air, and these are updates that once you've compiled your code and you've got your code in a particular place, you want to just whiz it up over the air through the Wi-Fi and onto that device. So we're going to get to that point as well. So because it now means that on that device you saw on my workbench, I can change the code and then update that code on that device without me having to go out into the garden or the beehive or the back of the shed or something and try and get a USB plug in there to upload new code. Don't have to do it. It's all over the air and it works very well, and we've got a developer to thank for this. So next steps is right back. We're going to wind back the clock. Here we go. I'm winding it back because we're going to go to step one. How do we get any of this working? And yes, we are focusing on an ESP32. It does work for an ESP8266, but you need slightly different libraries. Not a huge thing, but don't ask me questions like that because I don't use the ESP8266 anymore. It's just the cost differential between that and the ESP32 with its dual core, massive amounts of RAM, PS RAM if you want to pay the money for that as well. It just doesn't make sense to me. So ESP32 it is. First of all, some prerequisites. As you can see on screen, there are in fact two windows there with exactly the same code in. One is the Arduino IDE version 2.03, and the other one is Visual Studio Code running PlatformIO. The code is absolutely identical in every respect. The difference, of course, is how the libraries are installed into each environment. Now, I'm going to assume that if you're running the Arduino version, you know how to put libraries into your Arduino environment. And similarly, for PlatformIO users, I assume you're very familiar with PlatformIO.ini and how to put the library definitions into there. Remember, the full code for both versions is up in the GitHub, so if you've got any questions, go and look there first. But I cannot show you how to install those libraries. It just takes far too long in this hopefully short video. Right, we're going to rattle through this because you can read on that screen as well as I can. I just want to explain a few things along the way maybe, right? So you've included the three libraries, including also this Wi-Fi library now, which you're going to have to use. Obviously, it's the standard Arduino Wi-Fi library to connect to your Wi-Fi. Here, I've said I want a specific IP address for this ESP device, because if you don't do that, what's going to happen is your router at home is going to talk to that device because it will say, oi, I'm here Wi-Fi, I'm connecting to you, I've given you my username and the password, which of course you must know for your own Wi-Fi. I need an IP address ready so you can talk to me. And the router will go, well, okay, I'm going to give you this IP address, but it might not be the same next time, which is a bit of a problem when you're on your phone trying to connect to the thing and it's not there anymore because the router's moved it to another location, another address. So what we're saying here is, no, I want this to be 192.168.1.103. Now your local Wi-Fi probably is going to be 192.168.1. something, but everybody's different. You might have a dot instead of the 1, you might have a 0, you might have a 2, you might even be on a 10 dot local network. But if you are, you probably know why you are. Just make sure that the format of this address here is pretty much the same as your other IP addresses. Now 103 is unused in my system. It has to be unused. You can't have two devices on the same IP address. When you specify that here, it will never, ever move. It will always be 103. So you can always find it again in your browser when you type in that address. The gateway is the address of your router, so it knows how to get there. And the subnet is always that. Don't change it. Okay. Now the first thing we do, look, is create a web server. After all, we need to do that in order to connect to this device. Right, so having set this up as a global, we need that as a global, of course, because it has to exist throughout this entire sketch, never goes away. In the setup, what we're saying is the mode of this particular web device is that it's a station, a client, in other words, not a web server standalone. It's a station, a client, but can be accessed. We do not want to persist the credentials for this device, because if you get them wrong or you change them, it's hell's own game trying to get them changed again, because the old device constantly uses the old one. So just say false there. Do we want to auto connect if we drop the connection? Yes, of course we do. Do we ever want to go to sleep? Well, yeah, fine thing. Your ESP goes to sleep just at the time where you want to connect to it. No, of course we don't. So we say false to the sleep. So then we do the Wi-Fi config, all that stuff we set up previously. Put in Wi-Fi begin with your SSID and your password. And no, that's not my password. We just log the result. And then we say, let's register some pages. Having told the device how to connect your Wi-Fi, that's all right, and it'll connect, but it's dumb at that point, isn't it? Nothing's happening. So what we need to now do is say, right, when you get a request from somebody, and I'm going to assume at this point you're using your phone's browser and you've typed in 192.168.1.103, which is exactly what we've told it we want up here, although you can choose any number there that fits in with your network better. Don't use the low numbers. Make sure it doesn't conflict with anything else. The higher numbers are probably better. Up to 252, I would say. Don't go beyond 252 because you'll probably conflict with routers and goodness knows what else. So when we say down here, we're now going to try and connect to that device. That device is going to say, I'm sorry, I've not been told what to do when you try and connect to me. Off you go. Not very helpful. So what we say is, the first thing we say is, if you can't find a page that the user is trying to connect to, you've tried to get onto 103/give me a page, which doesn't exist. It goes, I don't know how to resolve that. I'm going to send you back a not found. And this is the absolute simplest not found that I could ever construct. It's just a little bit of text that comes back to your browser going, couldn't find it. Well, actually it says 404 page not found. Oops, but that's about it, right? Simple. Obviously not found pages can be quite detailed. They can have graphics on them, all sorts of things, menus. We're not doing that, not here anyway. So cool, your ESP32 device is now connected to your network, but it's pretty dumb, nothing's happening. We're not talking to it and it's not talking out. It's just connected. But by typing in its IP address, in this case 192.168.1.103, it means that yes, your request will be routed by your router in your Wi-Fi environment down to that device, and the device will be, oh, what page do you want? Well, you've not actually given it a page, you've just given it the address of the device. And implicitly at the end of the IP address, you've put a slash. Now, whether you typed in that slash or not is almost immaterial. The system knows that there should be a slash, and it will put one in there if you haven't. Now, of course, if you wanted a proper web page, you'd have to type slash and then the name of the web page. But if you don't type anything, it will still put the slash in for you, which is why that slash up here is defined like this. It goes, when a request comes in for a blank page, a nothing, just the landing page, this is what I want you to do. And what it wants the system to do is say, well, first of all, this is an HTTP GET. I'm not going to try and explain the difference between GET and POST and all that. We'll just move on. What we need to do, though, is say, I've got to send you something back. Obviously, you've gone to the server. The server has got to send you something back, and pretty quickly, too. After about 4 seconds, the environment will go, nothing happened. I'm going to error that and send you back some sort of error. And your browser will probably give you an error then going, nothing was sent back. Sorry. And it just stops at that point. So what we're going to send back is this async web server request. And this async web server request contains a response. Here's the response here defined. And what we're saying is we're giving you back not just plain text like we did with the page not found. We're going to give you back some HTML. So it looks nice. Yeah, it's a proper web page in this case. And that's how we do it. We set it up like this. Now the response itself contains HTML, which you can read as well as I can in this bit here. And I've formatted it like that so you can see the structure. Now, if you do not know HTML at all, you know, this is the first time you've seen it, I've got to be honest here and say you need, if you're going to do this sort of thing, you need to learn a bit about it. It's pretty simple initially. You could certainly learn enough to get some decent web pages back just by using some simple constructs. But if this doesn't even look like a construct to you or some sort of system, then you need to read up about that and practice it a little bit more. Tip for you: if you create a shortcut or a file on your PC and call it, as an example, test.html, when you double click that will load up in your browser, so you can write HTML like this to see what it looks like in your browser without having to go through the entire paraphernalia of uploading it to your ESP32 first. Do that in your browser and your PC or Mac, and just see what looks proper, what works, what doesn't, and that will be a lot quicker development cycle. But basically HTML, all the keywords are enclosed in chevrons, as you can see there. The word HTML is enclosed in a chevron, and for every keyword that's enclosed in the chevron like that, there is somewhere a corresponding slash keyword like the one down there. So that ends that. Okay, and throughout this tiny bit of HTML here, you'll see that repeated. There's a header there, head, and there's the end of the head, and there's a style, and there's the end of the style, and there's the title of the page we're going to, and there's the end of the title. And yes, I did write that all in one line, basically because that's convention basically when you're writing HTML pages, but don't worry about that. Now, the actual browser doesn't care how you write that. You could write all that HTML there that's in red all in one line if you wanted to, or you could write it with 1,000 spaces between each word and it wouldn't care. White space to HTML is nothing. We only write it like this so that we humans can read it. If you've ever looked at any HTML that's been generated by systems, it's an absolute mess. It's almost impossible to follow. What are we doing here in this HTML then? Well, the header simply describes what's coming next. So we've got the title, there's a little bit of styling here. So we've changed the background color of the body, for example, and told it which font to use. But then we get onto the real interesting stuff, which is the body. And the body of your web page is the bit you actually see. Yeah. So within an H1, which is a header of the first order, so it's a big header, the biggest you can get, we've said this is a landing page. And then we've described a paragraph. There's the start of the paragraph, there's the end of the paragraph, /b. And this is what we put inside our paragraph. Yeah, really exciting, isn't it? And that's all I did really. And I said, well, that's the end of the body, and that's the end of the HTML, and that's the end of this whole raw string that I've defined here. What's that? What's a raw? Well, it's a raw literal, and by typing in this construct at the beginning means everything we type in now, even though normally you might think they are somehow going to be confusing to the code. No. So I'll put semicolons in here and quotes and all sorts of things. Actually, I can't find a quote, but anyway, if you did put them in, you don't have to escape them. It's literally, as you type it in, it will be sent out. And that's a very useful thing to do, a raw literal. I'm sure there's web pages that describe exactly how to set those up. Anyway, having put all this into the response object, we then send out that response object via the request. So we say the request that's come in from you, yeah, we're going to send back out now, and here it is. So not only does this come out like this, the system understands what it is you're trying to send out. Your browser understands the response and goes, oh yeah, this is great, I understand exactly what you're sending me back, and kapow, what do we get? That is what we get, because that is what we just saw typing in. Oh, no, I've still got one of my downloads showing. Let's get rid of that. So there it is. And if you were to take this code and get it working, yeah, make sure it all works on your system, you can then change it to suit and put in more paragraphs, or if you know HTML, you can put div blocks and spans and all sorts of things in there and make it look quite nice. Now, I said at the beginning of this video somewhere that by using the ESPAsyncOTA library, it gives us a free way of updating code on that device without going through the USB cord. Now, you're going to have to take my word for this, because I've got to keep the USB cord connected just to keep it powered up, but we're not going to use that to upload the code. Let's have a demo, shall we, of how we can do that. So in the code here, it says the background color of the page is yellow. What would happen if we typed in, I don't know, forest green? Fine. Now we need to compile that. Well, on the Arduino, you compile things up here, isn't it? Not upload. We're not uploading. We're just compiling or checking our sketch. Yeah? So on the PlatformIO, it's down here. So we're just going to generate a little bit of code. Now we need to upload that code over the air to that device. How do we do that? Well, we need to go to the browser now to do that. So here we are in this page, look, 192.168.1.103 update. Because if you want to go to a proper page, you do need the slash in. It's not implied anymore. You really do have to type it in. And you get this page created by Mr. Ayush Sharma. Right, okay. And it says, okay, well, where's your file then? Well, on the PlatformIO system, I'll show you. So within my PlatformIO environment, I've gone to where it says projects. Under my project, there's a .pio folder. Open that. Within that, there's a build folder. Open that. There's an ESP32 dev folder. Open up, and here we have all the code that it compiles. Forget all the libraries and sources, but we're looking for one that says firmware.bin. Has to be a bin file, and that's the one we've just compiled at 1434. So we double click that to select it, and it will start uploading immediately. Let's do that. There it goes, uploading. Whilst that's uploading, let's see how we do exactly the same using the Arduino IDE. Now in the Arduino environment, just go to your sketch as per normal, but instead of clicking that little tick box to get your code, go to sketch, click that, and scroll down to the bit where it says export compiled binary and click that. Now what that's going to do is compile your program as per normal, but move a copy of it into the same folder as where your sketch is. And presumably you know where your sketch is, but even if you don't, you can go back to sketch when it's completed. There it is, it's just about coming to an end. Right, it's done it. Go back to sketch and say show sketch folder, Alt Control K, and here we are. It's opened up that particular folder of the same name where the sketch is, and this build folder is the new one that's now been exported. Double click that and double click that, and here are all the files that have been generated. Some quite long names, look, but the bit you want is the bin file. Okay, so this top one here is the one that's your actual sketch, not this bootloader bin. Don't want that. We don't want the partitions bin. That's something to do with the ESP32 partitioning. That is the one you want. Okay, that is the thing to upload using OTA. And you can see it's pretty quick. Depends how big your code is, of course, but it does it without that USB connection. It says I've done it. How do we know? Well, this is the browser, but unfortunately I'm in my monitor at the moment. I'm going to go over here. I'm going to go back a page. So this is the old page in the history of my browser. But if I now refresh that by pressing F5, we hopefully should get the updated page downloaded. Now you've got the updated page, and you can see that it's pretty easy to make simple changes. Of course, to get that page to do anything meaningful requires a little bit more work. We might do a part 2 of this sometime in the future. If you like this and got some stuff to tell me, put comments down below, and where you think perhaps it could be improved, or if you've done it already, that'd be good. If you thought this was mildly entertaining or useful to you in the future, please do put a like, a
hey,
yay, exactly, because YouTube then will make this video available to more people, or at least offer it to more people. And if you like these sort of videos, remember, subscribe, tick the bell in that order, and you'll hear from me again when I next release a video. Yay! See you then. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.